Okay, so we're going to begin chapter 5, and we're going to talk about exponents and polynomials. So this is sort of a shift from where we were in chapter 3. If you remember, in that chapter we were talking about graphing and slope and all of those things related to equations with two variables. Well, now we're going to shift, and we're going to really kind of get to the introductory part of dealing with other types of equations besides linear equations. And we're not going to graph other types of equations or anything in this chapter, but we are going to at least introduce how to work with polynomials and work with exponents. And so the first couple of sections are going to really focus on exponents, and then the last part of the chapter gets into dealing with the polynomials. So we're going to jump right in and look at some basic things that you need to be aware of. Again, I'd like to teach this class as if you don't know a whole lot, and so I try to begin it at the bottom and kind of work our way up. And so when we talk about exponential expressions, what that means is we're taking an expression that has an exponent, and we're going to do things with it. So when we talk about this exponent, again, that's something we need to kind of define. In this expression 5 to the second power, or 5 squared, the 5 is what we call the base. Now, that is the number that is getting multiplied times itself. The 2, in this case, is what we call the exponent. The exponent tells us the number of times to multiply the 5. So when I ask you to evaluate 5 squared, by the way, if it's a power of 2, we call it squared. So I'll make a little note of that. Exponent of 2, we say squared. And if it's an exponent of 3, which we haven't seen yet, but we will, we call it cubed. Okay, so just be aware of that. You'll see that as we move forward. So in this case, when we have 5 squared, if I ask you what 5 squared is, you can tell me off the top of your head. But I promise you somebody in your mind is thinking 10. Because you're seeing 5 and 2 and you're multiplying those. But that's not what this says. What this says is that we're going to take 5 and multiply times itself 2 times. So it's 5 times 5. And you probably know that, but in your mind, when you see the 5 and 2, maybe you say 10. And so we want to make sure that we understand it's 5 times 5, which then simplifies to 25. And so as you are doing this, you are going to see a lot of times I'm going to encourage you to write out what it literally means. So 5 squared literally means 5 times 5. And I encourage you to write that out, because if you'll do that, then you're probably not going to mess this up. Now look at the next one, 3 to the 5th power. Well, again, if I ask you what is 3 to the 5th power, you may say either I don't know, or you may try to say 15. But again, it's not 3 times 5. What it literally means is that we're taking 3 times 3 times 3 times 3 times 3 5 times. And then when you multiply all that together, you get 243, which is the correct answer here. Now, let me give you a little illustration. I was teaching this several semesters ago, and I had a student, as we were talking about this, I told them that in every single class, I have students that will say 3 times 5 instead of 3 times 3 times 3 5 times. And so I was trying to make a point and really kind of harping on the fact that there are going to be people that say 3 times 5. Don't be that person. Don't be that person that makes that mistake. And so I have this guy in my class, and he goes, nobody in here is going to do that. Nobody's going to do that. And I said, I guarantee you somebody is going to do that. Somebody's going to say 3 times 5. He goes, nobody's going to do it. He kind of looked around the room saying, right, nobody's going to do that. I was like, I hope you're right, but I can promise you somebody's going to do it. So on the test, I gave this same exact problem, 3 to the 5th power. That guy was the one that said it was 15. My point here is that even though you might know in your mind that it's 3 times 3 times 3 times 3 times 3, if you're not careful, you may say 15 instead of 243. So until you get really good at it, I highly encourage you to write out literally what it means. Now, somebody say, well, I don't know 3 times 3 times 3 times 3 5 times. Well, this is one that you'll need to memorize. Before we get through this whole section, you will have seen probably 3 or 4 times 3 to the 5th power. So you'll memorize that it's 243 by the time we get finished. You can kind of go ahead and be making a note of that, because that will be something that's pretty common. Now, if we have a number or a letter that does not have an exponent, it is always an exponent of an understood 1. Okay, so you can see that here. So for any number, any letter, if it doesn't have an exponent, it's always an understood 1. Obviously, if it does have an exponent, then we'll talk about how to work with that. Alright, so let's do this. Let's take 2 times 2 times 2 times 2, and let's write that in exponential form and evaluate it. So in exponential form, our base, again, is the number getting multiplied. So this is 2 to a power. And the exponent tells us how many times it's being multiplied. So you can see that it's being multiplied 4 times. So we're going to write this as 2 to the 4th power. And then we need to evaluate it. Well, again, because it is 2 times 2 times 2 times 2, you can multiply that. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And so we can find that solution. As an exponential, it's 2 to the 4th power. But when we actually evaluate it and we tell that number, then it is 16. Now, I want you to look at these next 4 problems. We're going to evaluate each of these. And we're going to talk about base and exponent. And then I'm going to go back and kind of explain with all of them together why the answer is what it is. Okay? So, excuse me. First one, we have negative 2 to the 5th power. And if you don't know, if you multiply that out, you get negative 32. Again, we're going to evaluate all these. We'll come back and talk about base and exponent in just a minute. The next one is a negative 2 to the 5th power. That also is negative 32. On the next one, we have a negative 4 squared, which is negative 16. And that may kind of throw some of you for a loop, so hang tight. We'll talk about that in a second. And then on the last one, we have negative 4 squared, which is positive 16. And so one of the first questions that I always have is a hand goes up and they go, wait a minute, how is that third one negative 16 and that other one is positive 16? And that's a great question. But it all has to do with the base. Okay, so let's start with that, and I'll kind of work backwards here. On the last one, this negative 4 being in parentheses, the 2nd power. What that says is that the negative 4 is being multiplied by negative 4. And we know negative 4 times negative 4 is 16. So the base, in this case, is negative 4. That is a number getting multiplied. The exponent is 2. Okay? That's probably not too difficult. Most of you probably can see that. But on the third one, the base is positive 4. Now, some of you, again, I've done this enough that I know what the looks are. Some of you are probably looking at your screen saying, wait a minute, how? Well, the base is always what's directly in front of the exponent. So on this last one here, notice that in front of that power of 2, you have this set of parentheses. Well, that means that anything in that parentheses is the base. But in this third one, what is directly in front of that that 2 is the 4, right? Directly in front of that exponent is the 4. So the 4 only is the base. And so when we talk about, well, how is this going to be negative 16? Well, what your calculator would do if you were to punch this in a calculator, and what you need to be doing, because again, we've talked about order of operations, is you need to look at this as negative 1 times 4 squared, because that's really what's happening. And so order of operations says you do exponents first, so you're going to square the 4, and you're going to get 16. And so it's negative 1 times 16, and then you multiply, which gives you the negative 16. And so this is a place where I see people really get confused. That's why when I substitute a number in to an expression, I'm always going to put parentheses around it, because that negative, if it's getting squared, well, the negative has to be squared, because if we leave it off, well, then we have the wrong answer. And so we have to understand what is the base. And so in this case, the basis for the exponent, sorry about that, is 2. Okay, now, look at the second one. Again, we're working backwards here. What is the base? Well, the base in this case, again, what is directly in front of that exponent is just 2. Exponent is 5. And then on the first one, the base is negative 2, because what's directly in front of that exponent is the set of parentheses. So anything inside that is our base. The exponent is 5. Now, I have people ask all the time, well, why are both of those negative 32? Well, it all depends on the exponent. On the first two, the exponent being 5 is an odd number. And if you were to take 5 negatives and multiply them together, so let me draw a little illustration here. So let's say we have 5 negatives. Well, if you multiply 2 negatives together, you get a positive. If you multiply 2 more negatives together, you get a positive. A positive times a positive is a positive, and then that times this other negative ends up being a negative. And so if you have an odd number of negatives being multiplied, whether that's 3 or 5 or 7 or 9 or even just 1, then your answer is negative. And so in this case, it doesn't matter if the negative 2 gets the power and gets raised to the 5th power, or if it's 2 to the 5th, which is 32, and then we make it negative. We end up with the same thing. But you need to understand that in this second example, it is 2 to the 5th power, which is positive 32, and then we make it negative, because again, order of operations. In the first one, the negative 2 is getting the power, so it's negative 2 times negative 2 times negative 2 times negative 2 times negative 2. And so when we do that, we have negative 2 raised to the 5th power gives us still negative 32. With the last two, with the 16 and negative 16, because we have an even exponent, then it matters. So 4 squared is 16. Negative 4 squared is also 16. So in this last one, it's negative times negative, which is positive. Ooh. And in the third one, it's 4 squared, which is positive, and then we make it negative. And so that's where our difference comes in. It's all about the base and then what the exponent is. Okay?